12.1, 12.2, we covered limits. We had a lot of practice with limits. Now we're going to apply it. How do we find that tangent to the slope of the tangent line to a graph? Okay, so and so you're going to be able to find the slope of the tangent line to the graph after this lesson, which is a big thing in calculus. Okay, it's called taking the derivative. So you're actually going to learn how to take the derivative using the definition of a limit, okay, using the difference quotient. So the first thing you see on page 826, we have, let's draw some parabola in here, and let's just talk about tangents to a function. In this case, our function is a parabola. So if I pick a point over here, okay, and I make a tangent line, right, a tangent passes through a function how many times? Once, right? So that's a tangent line at that point. And that line has a slope, and we're interested in what that slope is. Okay? And then right here, so let me pick another point, and this is just some point xy. I could pick a different xy over here and make a tangent line over here. If I made a tangent line over here, would the slope be the same as the other slope of the other line? No, it'd be a little different, right? If I picked a point up here on the graph, what would my tangent line look like? It'd go across, right? So what would the slope of that line be? It's the slope of a horizontal line. 0. So the slope of this line, we don't even have to calculate that. That's 0. Okay, that's always going to occur at what kind of point? What kind of point is this? What do we call that? The vertex, right? Yeah, like a vertex. So, or the maximum or the minimum, right? So your slope is going to be 0 at a maximum or minimum. Now if I come around here and I pick a point over here and I draw a tangent line to it, it's going to go like this. Okay, now my slope is going to be what kind of number am I going to get over here? It's a negative slope, right? So it's going to be a negative slope. If I pick a point over here, am I going to get a positive or a negative slope? Negative, and it's even steeper, right? So slopes that are closer and closer to 0, between 0 and 1 are going to be between 0 and 45 degrees this way. Over 1, like let's say, I don't know, let's just say this slope is negative 4. And let's just say this slope is negative 8 or something like that. So it's really steep, and it's getting steeper. Okay, the slopes on this side, what were the slopes on this side of the parabola? Positive or negative? These are positive slopes, and notice the function is going up, so we have positive slopes, and then it goes to 0, and then when it comes back down, then my slopes are negative. Okay, so it's always going to happen as your function is increasing. You have positive slopes, then maxes out at 0, then it goes decreasing and negative slopes. So in calculus, that's what you study a lot, is what are the slopes of, what's the rate of change of the slopes as we go along a function. Okay, so that's the beginning of what we're going to be doing today. So some other graphs that your book has is, if we just have some graph like this and we pick a point right there, what would the tangent look like at that point? Just be something like that. It's positive or negative? Positive slope, right? And then if I have a graph that's decreasing like this, like some exponential decay or something like that, and I pick a point right here, point P, I draw the tangent line of that. Is that positive or negative? That's a negative slope, right? And then lastly, let's say we have, this time we have our parabola going up instead of down. And I pick the vertex again. You said the vertex, so if I pick the vertex, what should the tangent line look like? Horizontal, right? And we know the slope is 0. So, positive tangent line slopes, negative tangent line slopes, and 0 slopes at maximums and or minimums. Okay, so that's just a review of how to draw a tangent line and whether they should be positive, negative, or 0. Okay. On example 1 in your book, I'm not going to make you write this down just because it's estimating the slope. So let's say we have this graph right here. So we have some parabola, it looks like x squared, and we want to know, they're picking 1, 1. Okay, so they're picking this point, 1, 1. Here's my equation, x squared. We want to know, let's guesstimate the slope at this point of this tangent. So let's draw in the tangent, right? And if we estimate, I'll say, oh, I'll count from like this point over here to this point, you know, if I put a dot here. We're going down 2 over 1. Actually, it's like up 2 over 1. So what is the slope of that line right there? 2, right? 2 over 1. So to do the slope, we do the change in y over the change in x, or which we commonly call the rise over the run. And our rise over run is 2 over 1. So the slope of this line approximately is 2, right? We're just approximating. So sometimes your book is going to ask you to approximate. Okay, if it asks you to approximate, just look at it, pick 2 points on the line, do the rise over the run, count that little slope triangle, and you have it. Okay, example 2, let's see if I can get this in here. Example 2, we have like a word problem, same kind of thing. So this graph depicts the average daily temperature in degrees Fahrenheit for each month in Dallas, Texas. Approximate the slope of this graph as at the indicated point and give a physical interpretation of the result. So this is the temperature in Dallas, Texas from January to December, right? Years month 0 to month 12. So what month are we looking at right here? Month 10? October. So we're looking at October. What does the 68.65 tell us? The temperature in October in Dallas, Texas is about 68.65 degrees. Okay, let's try and draw the tangent line at that point right there. So I draw the tangent, I pick 2 points, I look at my slope, I have 2 over 20, but that's not the slope. What is the slope? My slope is, it's really 20, it's really down 20 over 2, right? And that's a negative slope. So down 20 over 2 is going to be, you can barely see right there, down 20 over 2 is negative 20 over 2, which is negative 10. If I put it a little higher, there we go, negative 10 degrees per month. So that means that at that point, at that exact point, the degrees change is negative 10 degrees per month. Just at that point. If I switch the point over here, it's going to have a different slope, right? To month 11, November. If I switch to month 12, it's going to have a different slope. Okay, so that's what we're interested in finding. What is the rate of change at a certain point in time? Okay, so next. On the next page, we have the slope and the limit process. And let's find out how we find the slope of a line. So, we're going to look at this graphic that's in your book. I'm going to draw it a little bit. So, we have this point xy, right? And this has to do with that video that we watched last Monday, you know, and he was talking about, I want to find the slope of this the tangent line at this point, like right here. But I only have 1 point. Right? And you can't find an equation of a line with just 1 point. How many points do you need? You need 2. So let's say I pick 2 points on the curve. Like this will give me a slope. Is it going to equal this slope? No, it's going to be in the ballpark, but it's definitely not going to be equal to that slope. So let me find the slope of this line by doing the rise over the run. Okay, so first of all, since this coordinate is xy, this distance from here to here is x, right? Okay. Now let's say we pick a distance far away from x, another point away. We're going to call that distance h. Okay, so this distance is going to be h, and I could put h right here. So what is this total distance? If I want to make a coordinate from here to here, what would this coordinate be? It would be x plus h, exactly. So so my coordinate of this point right here is x plus h, like that. Okay, that's my x coordinate. Now I need to work on my y coordinate. Well, my y coordinate right here, up to here, is y, or f of x. I should put f of x, not y. So replace that with f of x, same thing as y. And then to get the coordinate up here, I would, since this is f of x plus h, since this is x plus h, the distance up here would be f of x plus h. Okay. So since this is x plus h, to find my y coordinate, I plug in my x plus h into my function to get f of x plus h. Well, I don't want that whole distance. I don't want this whole distance from here to here, right? I just want from here to here to do my rise over run. So I need to subtract 2 things. I need to subtract my f of x plus h minus my f of x, right? So this distance is f of x plus h minus f of x. That's the top half of your difference quotient, right? So if I want to find the slope of this secant line, this stands for secant because it's a secant, I'm going to take this top half divided by this half, and if you look at that, that's f of x plus h minus f of x all over h. Oh, we've been doing that for a while. That's called the difference quotient, and that's why we've been doing the difference quotient. It's not some random thing, it's how you find the slope between 2 points, okay, on any line. Okay, think of it as it's just a different form of y2 minus y1 over x2 minus x1, right? That's all we're really doing. This is my y2, this is my y1, and my x2 minus x1 is x plus h minus x, gives me just the h. Okay. So, wow, that's how we find the slope. So if I have this slope, it's not really accurate, but let's make the points closer together, and then let's make them even closer, and then let's make them even closer, so that they're so close that it looks like it's almost the same point, right? Or it is the same point. What do we call that? How do we do that? We call that the limit, right? So we're going to take the limit, or here's the definition of a slope. We'll write definition of the slope, and I'll write more stuff, is we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to take our difference quotient and we're going to make that distance between the 2 points get closer and closer to 0. And so the points are going to be really close together so that it's close enough to give us the slope. Okay, so that's the definition of the slope of a graph. The slope m of the graph of f at the point, we're supposed to write this, at the point, so at the point, alright, it's x comma f of x. Usually we put x y, but instead of y, we're replacing that y with f of x now. Okay, so you're going to see x f of x a lot now instead of x y. Of the tangent line, so this is the slope of the tangent line. Of the tangent line at x f of x is given by this equation right here. Okay, which is, so we're just taking the difference quotient at these 2 points. Okay, so let's look at example 3. We'll do example 3 together. We have enough room here on the next page, and we'll put this to use. Let's put this equation to use. It says find the slope of the graph f of x is equal to x squared at the point -2, 4. So what does f of x equals x squared look like? It's just a parabola, right? Centered at 0, 0. Okay. And I know it passes through -2, 4. So -2, 4, let's say -2, 4 is like up here. Okay, and then let's do, ignore them. Let's do the tangent line. Let's draw the tangent line. Is that a positive or negative slope right there for that tangent line? Negative. So I know my answer should be negative, right? And so we're going to look at our equation that we have. We're going to use this equation. Let's rewrite it. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and since they're giving us a point to plug in, they're giving us, what, -2, 4? So this is the point they're giving us. All we really care about is what is the x equal to. Okay, I'm not even going to use this y. The y is irrelevant to our work. We just care about where the x is. Okay, so since my point is -2, we're going to plug in -2 in for my x coordinates right there. Okay, so that's going to give us f of -2 plus h minus f of -2 all over h, as I should have put it equals there, as the limit of h approaches 0. Erase that equal sign. Okay. We're just plugging that -2 in for x. Okay, well, what is f of -2 plus h? Okay, we need to, so our function, this is our function, f of x equals x squared. So what is f of -2 plus h? So wherever there's an x, you're going to plug in -2 plus h, and we're going to square it because that's what we did to the x. Okay, so I'm going to take this function minus this function. I'm going to take this minus this. So I'm going to take this part and minus this part. So really all I have is I have -2 plus h squared minus, and I could take f of -2, right? Well, f of -2 is just 4. I actually am going to use that for this part because they gave me a point. If I plug in -2 into here, -2 squared is 4. Okay, all over h. So the limit as h approaches 0. Okay, if I were to put h0 in for h right now, I'm probably going to get the indeterminate form 0 over 0, because whenever you use a different quotient, that's what you're going to get. And that's not useful to us. So somehow we need to get rid of, we always have to get rid of this h somehow. Okay, but first of all, let's multiply this out. So what is -2 plus h times -2 plus h, which I don't like writing that way. Let's reverse this. What's a better of writing -2 plus h? Yeah, h minus 2. That's a lot nicer, right? We're used to that. So if I multiply h minus 2 times h minus 2, I'm not going to get 4 plus h squared. Okay, that's going to be wrong. If you put 4 plus h squared, you're going to get it wrong. I already had one person do that yesterday on her homework, and she couldn't figure out what she was doing wrong. It's h squared, and then this is a minus 2h, and this is a minus 2h, right? So you get a -4h. And then the -2 times the -2 gives you a plus 4. So you get a trinomial. Whenever you square this binomial, you better get a trinomial, not a binomial. You're not just going to square that and square that. No, that's wrong. Okay? And then -4. This -4 always needs to cancel with something over here, and it does. So this +4 right here, this -4, they make 0. Okay? Over h, as the limit of h approaches 0. Okay, now we have just a bunch of stuff with h's on the top and an h on the bottom. So let's factor out our h on the top. If I factor out h out of here, I'm going to get a h minus 4 all over h of the limit as h approaches 0. Now I can cancel out this h, okay, and I won't get 0 over 0 anymore. So, you know, those become 1s. Now I can put in the 0, and I get 0 minus 4. So the limit, which is -4. So the tangent of this, the slope of this tangent is -4. So that's our slope of our tangent line. So we now know how to find the slope of the tangent line, and all I needed was the point that it was at. I didn't need to pick another point because we have this limit process. It told me that the slope of this line is going to be -4. Okay? So that's one example. Okay, what if they don't give us a point and they just want us to find the equation of the tangent line? We can do that too. So here's example 4. Okay, example 4 says, appreciate the nod. Somebody nodded back there and said they understood what I was saying. Find the slope of, that was over there, f of x equals -2x plus 4. It always makes the teacher feel good when you don't get just blank stares, but somebody that actually acknowledges they understand what's going on. Okay. Oh, yeah, that's... Alright, find the slope of f of x equals -2x plus 4. Okay, so what kind of graph is this? Yeah, it's a line, so you can see the slope is -2. Why are we trying to find a slope? We're just trying to practice this, okay? So we're going to practice this. Let me turn on the air real quick. Colder. There's no air movement in here, so it needs to move. Okay, so we're just trying to practice this. We know the slope is -2, so we know what the answer is going to be. So how do you come up with an equation for the slope, you know, because you're going to have to deal with equations that aren't lines. So we're just practicing right now how to use this equation. So let's use our equation, the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and of course this is some line. Let's just graph the line really quickly. It starts at 4, 1, 2, 3, 4, and then it goes down 2 over 1. So down 2 over 1, down 2 over 1. So my line goes like that. And we know the slope of this line, you know, is going to be -2 over 1. But let's just use this process just to see if we can use it correctly. Okay, so first of all, we need to know what is f of x plus h. And I like to write it right below the f of x to help me out. Okay, so this just means if this is f of x, all I'm going to do is wherever there's an x, I'm going to put an x plus h there. And write everything else the same, except I'm going to replace this x with an x plus h. If there's two x's if there's an x squared and an x, make sure you put x plus h for both of the x's, okay? And so that's going to be my f of x plus h right there. So it's just this guy, -2 times x plus h minus, now my f of x is just the original function. Oh, you have to put parentheses around this whole function, okay? Whenever you minus this f of x, there needs to be a big parentheses around it. Minus 2x, because you're minusing the whole thing, plus 4. Why does that make a difference? All over h. Because this negative is going to distribute, and it's going to make that +4 a -4. Always. It's always going to change that sign of anything after the first part, okay? So let's distribute this out. -2 times x gives us -2x. -2 times h is -2h. Negative times negative makes +2x. And negative times that +4. That's the one that people forget to do. Is like, oh, I have to change the sign and make it -4. Oh, I forgot a 4, huh? I did forget a 4. There is supposed to be a +4 right here because there's a +4 in the equation. I forgot it. Okay, because I needed to cancel with that -4 right there. So like I said, this +4 needs to cancel with something. It's that -4 right there. This 2x is going to cancel with that 2x, right? -2x, +2x. All we're left with is -2h over h as the limit of h approaches 0. Well, the h's, we can cancel those out, and we just get -2. We didn't even need to plug in the h. So this is our slope of our tangent line. You know, the tangent line is the line. It's very easy problem to do, but just practice. Okay, so there's two equations that you need to know. At the top of page 830, they give you two equations. There's the limit as h approaches 0 of f of c plus h minus f of c all over h. And then there's the other one, m equals the limit as h approaches 0 of the regular f of x plus h minus f of x all over h. Okay, we've been using this one. This is for when they actually give you a point, right? So when they actually give you a point, what you want to do is you want to plug in that x coordinate for c. Okay, c is the x coordinate, so c is your x coordinate. So like I said, you know, if you have some parabola, and let's say they pick the point, oh, I don't know, this is 3, 5 or something like that. So your x coordinate is 3. So you're going to plug in 3 right here. So it's going to be 3 plus h. And you're going to plug in f of 3 right there. Okay, so that's when they give you a point, a specific point you want to find the tangent at. I want to find the tangent at this point, 3, 5. Then you're going to plug in 3 here and 3 here, and then solve it. If they don't give you a point, then you just plug in x minus h into the equation, and you'll still have x's. right? So that's the difference between what we did in example 3 and example 4. In example 3, they actually gave us a coordinate, right, that said, hey, find the slope at negative 2, 4. So, okay, so we plugged in the negative 2 here and here. Okay, but example 4, they didn't give us a point, so we had to just use f of x plus h and plug that into the function and get some kind of equation, which we got negative 2. Usually there's an x in here. There's like a negative 2x or negative 2x plus 1 or something like that. All right, so let's try one more. Let you try this. Example 5, right below that, we have find a formula for the slope. Find a formula for the slope of the graph of f of x equals x squared plus 1. What is the slope at the points I'll just put the points negative 1, 2 and 2, 5. Find a formula for the slope of the graph of f of x equals x squared plus 1. So when they say find a formula, they just want the generic, okay? So they want you to use this equation when they say find a formula for the slope. When they say just find the slope at these points, then we want you to use this. So we're going to actually use this, okay? So let's write what our f of x plus h is. F of x plus h, instead of x squared, I'm going to put x plus h squared plus 1. You're going to do this a lot, x plus h squared a lot, okay? And let's do our limit. The limit as h approaches 0 of our, f of x plus h minus f of x all over h. And you should be getting to know this by heart. You're going to write this so much on your homework, so you're going to know it by heart. Okay, so the limit as h approaches 0. F of x plus h is x plus h squared plus 1. Minus my f of x, well, my f of x is this whole thing. I need to minus the whole thing, so make sure you put parentheses around this whole thing, which is x squared minus plus 1 all over h. Okay. I forgot to look at what this graph looks like. What does y equals x squared plus 1 look like? Yeah, it's a parabola that's just shifted up 1 unit, right? And later on, we're going to find the slope at negative 1, 2. Negative 1, 2 is like, say, right there. So we're going to find that slope at negative 1, 2. And then we're going to find 2, 5. So let's say 2, 5 is like up here. We're going to find this slope. Right? One's negative, one's positive. Okay. So this is going to give us a generic equation that we can plug in any point on the parabola to find the slope at that point, which is pretty handy. Okay. So the question is, how do you square x plus h squared? Okay, what is x plus h times x plus h? It's not going to be x squared plus h squared. Okay, you put that, you're going to get the wrong answer. That is not what that's equal to. Okay. It does have an x squared in it. It has an h squared in it, but there's this hx and there's another hx, right? There's hx here, so what's hx plus hx? 2hx, or I'll put 2xh. And then h times h gives you that h squared. Okay, so when you square this out, you're going to get this, not that. Okay, not just that. You don't just square those two. You have to get that trinomial. And then when I minus this, I get minus x squared when I do that. And then that plus 1 is going to change to a minus 1, and that better cancel with some, I forgot that plus 1 again, huh? I keep forgetting that plus 1. So I squared the x plus h squared, but then I forgot to put the plus 1, so I'm going to throw that plus 1 in there. I remembered because I said, oh, this minus 1 needs to cancel with something over here. So that minus 1, okay, is going to cancel with that plus 1. That's going to go, this x squared is going to cancel with something. This minus x squared cancels with that x squared. I forgot to put over h as well. Got excited and started canceling stuff. So limit as h approaches 0. Now I have a bunch of h's left, which is good. Okay, so I have 2xh plus h squared all over h as the limit of h approaches 0. Because right now, if I plug in 0 into here, I'm going to get 0 over 0, which is indeterminate. So I need to factor an h out. Always factor that h out. If I factor an h out of this, I'm going to get 2x. If I factor an h out of this, I'm going to get h, right? All over h. These h's go away. Now I will no longer get 0 over 0, right? When I plug in 0, now I'm going to get, now I just have 2x plus h, so 2x plus 0. So 2x is my equation. Whatever the x coordinate is, this is the equation for the tangent, okay? So whatever x is, so the other, let's say the first equation asked me what is the tangent at negative 1, 2. Okay, all I need to plug in is the x. All I care about is the x. X equals negative 1. So I'm going to plug in 2 times negative 1. So the slope of this line right here is negative 2. That's what we just found. Okay, now let me plug in b. The second point was 2, 5, right? So at 2, 5, all I care about is the x. X equals 2. I'm going to plug in 2 times 2 because the equation was 2x. So I plug in 2 times 2. That tells me that slope right there is 4. So the equation of this line is like y equals 4x minus something because it's going to go like way down here. And we could find that, you know, y-intercept. We haven't yet, but we could. And this equation is going to be y equals negative 2x, maybe just negative 2x. Okay, we could put that in our graphing calculator and play with it too. All right, so what have you just found? Ladies and gentlemen, you have just found what this guy discovered in the 17 or early 1800s. This guy, Augustin Louis Cauchy, a French mathematician. He developed many basic concepts that we use in limits and continuity. So he developed a lot of the stuff. You have just found the derivative. That's calculus. We take derivatives in calculus all the time. And actually, you take derivatives in physics. Okay, because when you do acceleration, velocity, position, you're taking the derivatives of those. How did they find those? Do you know those three functions are all related? Yeah. If you have the position function, right? So you have your position function, some s of t. Let's just say it's like negative 16t squared plus 14t plus 50 or something like that, right? That's your position function. The velocity function is related. The velocity function is the derivative of this function, which would be like negative 32t plus 14. And then you have your acceleration function, which would just, the derivative of this would be negative 32. So, yeah, so this is the derivative of that function. This is the derivative of that function. And if you knew calculus, you could do physics with your calculus. But I'm sure you haven't done much calculus in your physics class because you haven't learned calculus yet. So I'm sure your teacher could do it, but he can't show it to you until now because now you know how to do derivatives. Okay? So, yeah, that's what we use them for. All right, so 2 more examples. Examples 6 and 7. Yeah. Example 6, find the derivative. Oh, we need to define derivative, sorry. What is the derivative? The derivative of f at x is, it's just, this is the notation we use for derivative. We use f prime of x. That means derivative, that means the difference quotient. What is it? It's just when you do the limit as h approaches 0 of the difference quotient. That is the derivative. That's why that's so important, and we harp on it because it has many physics applications. Okay. So the derivative of f at x is, f prime of x is basically our difference quotient. Okay. And it's provided the limit exists. So that's a little caveat, provided sometimes the limit does not exist at a point. Okay, and I like the sentence underneath there. I'm going to make you copy the sentence underneath there. Remember that the derivative, I'll just put the derivative, that is redundant, it's unnecessary. the derivative f prime of x is a formula for the slope of a tangent line. So what are we finding? We're finding a formula for the slope of a tangent line. To the graph at the point. How are we going to write the point now? Instead of xy, xf of x. Okay. So the derivative f prime of x is just the formula to get the slope of the tangent line at the graph of at the point xf of x. That's all the derivative is. You're finding the slope of the tangent line at any point on the graph. Okay, so that's important. Now we can do example 6. It says find the derivative. So when it says, now they're going to start using that terminology, derivative. What do you do when it says find the derivative? Use the difference quotient, right? Of f of x. You're finding the tangent, the slope of the tangent line. 3x squared minus 2x. Okay, let me put this in our graphing calculator to see, because we know what type of graph it is, we just don't know where it is, right? So what type of graph is this? Parabola, it's an x squared. So let me put, correct equation in here. 3x squared minus 2x. I'll delete this other equation. Let me graph it. Okay, so the vertex is somewhere in the 4th quadrant. And it's a very narrow graph, so I'll go something like that. Okay, but we don't really care about the vertex. We want to find the derivative, which tells us where, the tangent at any point on this graph. So let's use our limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, let's write what our f of x plus h is. F of x plus h is going to be, we're going to replace this with x plus h, so 3 times x plus h squared minus 2 times x plus h. Okay, you see that? There was an x here, there was an x here, so I replaced both of them with x plus h's. Okay, so this is going to be 3 times x plus h squared minus 2 times x plus h minus this whole thing right here. I'm going to minus this 3x squared minus 2x, okay, all over h. And of course, I should put the limit as h approaches 0. Okay, so I need to square this, and we squared this last time. When I square x plus h squared, you guys trust me that it's x squared plus 2xh plus h squared, right? We square that. And then we're going to multiply that by 3. So we square that, we multiply by 3. Minus 2x minus 2h, and then minus 3x squared. And then this negative times this negative is going to change it to a plus 2x, and that 2x better cancel out with something over here. Oh yeah, it does right there. All over h as the limit of h approaches 0. So it's just a lot of things. It's not difficult. It's just multiplication. Multiply that out. Let's get 3x squared plus 6xh plus 3h squared. And can we get rid of this 2x and that 2x right there? Those go away. And then minus 2h minus 3x squared. So those two right there. All over h. The limit as h approaches 0. Okay, what other things cancel? See this 3x squared, that 3x squared. One's positive, one's negative. That goes away. And nothing else cancels. So I have this trinomial right here, but they all have h's, so that's good, because that's going to cancel with that h. Okay? So, if I want, I could say, oh, this h is going to cancel with that one. This squared is going to become a 1. This h is going to go away, giving me 6x plus 3h minus 2 as the limit as h approaches 0. Okay, so now I'm going to plug in 0 into here. I'm going to get 6x plus 0 minus 2, or in other words, 6x minus 2. So this equation, we've just found the derivative. I'm going to put f prime of x. Okay, f prime of x is 6x minus 2. So if I want to find, I can put, I can use my graphing calculator. I can put trace. There's a point at 1, 1. So if I want to find what the derivative is at, what the tangent, the slope is at 1, 1, I'll just plug in 6 times 1 minus 2 is 6 minus 2. So that tangent line at 1, 1 right here, that tangent line is 4. That slope is 4 at 1, 1. Okay. I can plug in whatever other point. I can plug in a point over here. I can plug in a point over here. Any point I want, I can plug into this function, and it'll give me the slope at that point. Okay, so that's what a derivative is. It's the slope of the tangent line. Okay. Let's try one more, which is a little different. This one has a square root in it. This is the last one. Example 7. Find f prime of x. Oh, and there are different notations for this. I say this because on the final, they use different notation than f prime of x, and there's several notations. So another way you can write, so derivative, hopefully I have enough room here. Derivative can be written as f prime of x, okay? It can be written as dy over dx, okay? You're going to see this on your final exam. I couldn't get the software to print this out, and so it just has this. So when you see this, know that you have to know that it means that, okay? And this means the derivative of y with respect to x. And then you could have this notation, that means the same thing. You could have d dx of f of x, okay? I don't think I've seen that too much. And then you could have dx of y. I don't ever remember seeing this notation. But the ones you're going to see the most are these three right here. Those you need to know. They all mean the same thing. So when you see this on your final exam, dy dx, it means to take the derivative. Okay? Okay, so having said that, find the derivative of the square root function, f prime of x, for f of x equals the square root of x. Well, that's a very simple function. Then find the slope. The slope of f at 1, 1 and 4, 2. Okay. So let's use our function limit of h approaches 0 of f of x plus h minus f of x all over h. What is f of x plus h going to be? I'll replace this with x plus h. That's it, right? All the x's, you replace them with x plus h. So it's the square root of x plus h. So I'm going to get the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Okay. We're going to get 0 over 0. Somehow we need to get this h to go away. We don't like square roots. We want to get rid of them. How do I get rid of this square root up here? Do what? Multiply by the conjugate, right? The conjugate is x, square root of x plus h. This minus, we're going to change it to plus the square root of x. So square root of x plus h plus the square root of x. So see that this minus and this plus gets rid of this middle term and this outside term. So we don't have to multiply those terms. We just need to multiply these two terms. So what is the square root of x plus h times the square root of x plus h? It's just x plus h. It's beautiful. The square roots went away. Okay, square root of x plus h times square root of x plus h is just x plus h. Same thing with this. Negative square root of x times positive square root of x is just negative x. The square root goes away. Okay. All over. Now the denominator, this is called rationalizing the numerator. Usually we rationalize the denominator. We've just rationalized the numerator. Now the denominator is going to look ugly, but that's okay. Oops, sorry, that's an h. H times the square root of x plus h plus x, and I should put parentheses around these. The limit as h approaches 0. Now notice there's an x here and a minus x here, so those actually like go away, right? Yeah, you're right. Thank you. That has a square root. So the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. See how there's an h on top? That's always going to happen when you rationalize the numerator. Okay, so that goes away. We need to put a 1 there. Don't forget, put your placeholder 1. It doesn't disappear. It's not a 0. So now I can plug in 0 into here since that h canceled out, and I can plug in 0 and I get the square root of x plus 0 plus the square root of x, which is basically 1 over the square root of x plus the square root of x, which is 1 over 2 square root of x. So the derivative, the f prime of x, or I'm going to write dy dx just to get you used to that notation, okay? The derivative, the dy dx, that is 1 over 2 root x. So they asked us part B at what points? At 1, 1. So I want to plug in 1 into here. So I'm just going to plug in 1. I just care that my x is 1. I don't even care what the y coordinate is, right? So 1 over 2 times the square root of 1 is 1 over 2. So the slope at 1, 1, and what does this graph look like? Square root of x, right? This is our graph. It's a sleeping half parabola, okay? And so at 1, 1, let's say 1, 1 is right there, that slope is 1/2, up 1 over 2. Okay. And then at the other point, at what, 4, 2, so 1, 2, 3, let's say 4 2's right there. We'll have this tangent, that tangent. All I care about is what is that the x coordinate is 4. I don't care that this y coordinate is 2. I'm just going to put 1 over 2 times the square root of x, so the square root of 4. 1 over 2 times 2 is 1/4. So the slope of this line is 1/4, up 1 over 4. Okay. And I can plug in any point I want to on this half parabola into this equation, and it'll give me the slope at that point, because that's what the derivative is. Okay? And that's it. Now you're ready to tackle the rest of them. When you do the first part of the homework, so do I want you to use the difference quotient on all of your homework? No, but most of your homework, yes. So the beginning is going to say, hey, estimate the slope. You don't have to use the difference quotient. Just look at it and estimate what's the rise over the run, right? And when later on it gets into the difference quotient, and then you have to use the difference quotient. So good luck.